Here's a small favor that I'm going to ask of you. When you see something that you think is cool, save the link and then send it to me at the email below. I can't promise that I'll include it in an episode, but I will go through every submission, and if it fits the show perfectly, well, you're going to get the credit for helping to make this show better. This first story comes from National Geographic. They have some amazing drone footage of Mount Etna and some other volcanoes. This particular piece is about a new study that was able to learn more about Mount Etna thanks to some rather unexpected drilling. Mount Etna is a very active volcano in Sicily, Italy. It's the tallest active volcano in Europe, and it frequently has lava flows and all of that fun stuff. But it's not just a random assortment of rocks and fire and brimstone. There's patterns here, and science can help us understand them. Scientists used to think that Mount Etna was made up of two separate magma chambers, but this research suggests there could be more like 4. Now, why is this important? Well, volcanoes are dangerous, and trying to predict how they work helps keep people safe. And this research suggests that the magma chambers aren't all connected. The magma might be coming from much deeper underground than we thought. The researchers drilled deep into the ground near Mount Etna. They were looking for water, but they found something else instead. Their borehole, which is like a hole you get in your tooth, went down 12 kilometers into the crust of the earth. And at around 9 kilometers deep, they hit magma. They weren't expecting that. That means that there is magma much deeper than anyone thought before. But wait, there's more. At 3.5 kilometers deep, they found another pocket of magma. This one wasn't surprising because scientists did expect to find magma there. But what was surprising was that it was almost like a layer between layers of rock. The magma had created a network of tubes or channels that it was flowing through. It was almost like a layer cake with different layers of magma and different layers of rock. The researchers are still analyzing samples from the drilling, so we don't know exactly how many magma chambers there are or how they're all connected. But this research shows that there are at least 2 or possibly even 4 separate magma chambers beneath Mount Etna. And here's the really cool part. They also found water 8 kilometers below the surface. That's way deeper than anyone thought water could exist. They thought the intense heat and pressure would prevent water from existing that deep underground. But they found water that had been around for 200 million years. Water that's been sitting in these rock layers for 200 million years. How do you like that? Next up, we have to talk about frozen frogs. In the UK, they found frogs that have been frozen for quite some time. Hibernating frogs can slow their metabolism down by up to 95% and survive without any need for food. Hibernation can help frogs deal with cold temperatures and food shortages, which can be especially tough in places like the UK, where winters can be pretty rough. These particular frogs were found by a group of researchers who were studying ponds in Scotland. They wanted to know how many species of frog could live in these ponds, but when they started surveying the ponds, they noticed something weird. The frogs didn't seem to be moving. They were all completely frozen solid. At first, the researchers thought that maybe they were dealing with invasive American bullfrogs. Those can survive being frozen for months at a time. But they soon realized that these frogs were native European common toads. Those can't normally survive like that. So then the researchers waited, and eventually the frogs started moving again. They had been frozen for almost 7 months. Now the researchers are studying these frogs to see how they survived. It seems like they entered a state called cryptobiosis. This is where an animal appears to be dead, but if conditions are right, they can revive. The frogs need to be supercooled, like less than 80 degrees Celsius, and they need moisture in order to do this. When they're frozen, their bodies produce molecules that stop ice crystals from forming inside of them. Normally, those ice crystals would damage the cells in the frogs' bodies, but not these frogs. These frogs are special. Frogs aren't the only animals that can do this. Tardigrades can also enter a state of cryptobiosis. The question is, how do they do it? No one knows yet, but it's pretty cool. That was the whole show. All right, you want more? We got a whole playlist of great short videos. There should be one right over there that the platform thinks you'll like. You know what I always say, eat more frogs.